name is cotangent theta cosecant theta, and I need to find my Pythagorean identity. Can you help me?
Oh, a girl! She could be my match! Wait, let me solve her. Cotangent x cosecant x is equals to cos x over sin squared x minus cos x cotangent squared x. So first, replace all trigonometric functions with just sin theta and cos theta. So cotangent squared x is equal to cos squared x over sin squared x. So cos x over sin squared x minus cos x times cos squared x over sin squared x. So cos x over sin squared x minus cos times cos squared is equals to cos cube x over sin squared x. So, and you can combine the two fractions because they have the same denominator. So, and you can also factor out the numerator. So cos x times 1 minus cos squared x over sin squared x. And 1 minus cos squared x is also equals to sin squared x. And cos x sin squared x over sin squared x is not equal to cotangent x cosecant x.
I'm sorry, but I am not for you.
Oh, a pretty identity. Well, second time's a charm. Let's solve her quick.
The quantity of 1 minus sin x times the quantity of 1 plus sin x is not equal to cotangent x cosecant x, because 1 minus sin x times 1 plus sin x is equals to 1 minus sin x squared, and it is not equal to cotangent x cosecant x, and 1 minus sin squared x is equal to cosine squared x.
La 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 la. I deserve someone better. You're not my match, boy.
Hi there, cutie. Are you my Pythagorean identity? My other half? Let's find out, cutie.
Cotangent x cosecant x equals tangent squared x minus sin squared x. So first, replace all trigonometric functions with just sin theta and cos theta if possible. Then you subtract the fractions. By subtracting the fractions, you need to find the LCD, and the LCD is cos squared x. So sin squared x over cos squared x minus sin squared x times cos squared x over cos squared x. So sin squared x over cos squared x minus sin times cos, which is sin squared x cos squared x over cos squared x. Then you can combine the two fractions because they just have the same denominator. So sin squared x minus sin squared x cos squared x over cos squared x. As you can see, you can factor out the numerator. So the factors are sin squared x times the quantity of 1 minus cos squared x over cos squared x. And sin squared x over cos squared x times the quantity of 1 minus cos squared x is not equal to cotangent x cosecant x.
Ah! This is so complicated! Well, there you are, honey. Let's go!
Hey there. What's wrong?
She could be my match.
Hey, why won't you solve me?
Cotangent x cosecant x is equal to cosecant x plus cotangent x over tangent x plus sin x. So first, replace all trigonometric functions with just sin theta and cos theta if possible. Then, identify the algebraic operations like factoring, expanding, distributive property, adding, and multiplying fractions. This will allow us to simplify the expressions further. So in the numerator, cosecant is just equal to 1 over sin x, and cotangent is equals to cos over sin x. And in the numerator, tangent is equals to sin over cos x and the sine. So at the numerator, you can simply combine the two fractions because they just have the same denominator. So 1 plus cos x over sin x, and in the numerator you need to find the LCD. So the LCD is cos x.
So sin x over cos x plus sin times cos over cos. So sin x plus sin x cos x over cos x. And by dividing fractions, you need to reciprocate the denominator. So 1 plus cos x over sin x times cos x over sin x times the quantity of 1 plus cos x. And by looking at the equation, you can cancel out 1 plus cos x. So crush out 1 plus cos x, the remaining will be cos x over sin x times sin x. And cos x times sin x over sin x is equals to cos x over sin x squared is equals to cotangent x cosecant x. And cotangent x cosecant x is also equal to cos x over sin x squared. And the two equations are equal.
Hey, we're a match, baby!
And that's how you prove Pythagorean identities.